Okay, we're back with part 2 of Algebra 2 Regions questions you must be able to do, part 2. I don't know if I'm going to have enough time to finish the whole thing right now, but we'll see what we can do. This is very similar to where we left off. Whenever I have 7, and out of 7 I want 1, 2, 3 things, I know it's going to be a P or C. Because there are specific positions, I'm going to do permutations. So I have 7, P, 3. To do that, I'm going to go to my calculator. I'm going to type in 7, math, PRB, P, 3, and I get 210. Permutations, positions, combinations, committees. If order matters, it's permutation. If not, if order does not matter, it's a combination. So let's jump ahead to number 69. A committee of 5 members is to be randomly selected from a group of 9 teachers and 20 students. I have 9 teachers. I have 20 students. Determine how many different committees can be formed if 2 members must be teachers and 3 members must be students. Well, I call these split committee problems. Because I need 2 committees. I need one for the teachers and one for the students. So it's going to be 2 separate problems. Out of 9 teachers, I need to choose 2. Out of 20 students, I need to choose 3. Because I need both these things to happen, I'm going to put multiplication between. For these problems, it's always a C. In this course, it's almost always going to be C. Unless you see specific positions, generally it's going to be C. Also, of course, if there's word permutations, it's going to be P as well. But generally, almost always, if you're not sure, choose C in this course. So 9 math, PRB, C2, and 20 math, PRB, C3, and 36 times 1140 is 41,040. 36, 1140, 41,040. Did I get that right? Yeah. So let's split committees. Very important type of question here. One of the most important in the course. Mornings when school's in session in January, Sarah notices that her bus is late 1/3 of the time. Okay. What is the probability that during a 5-day school week in January, her bus will be late at least 3 times? Out of 5, I want 3. That's NCR. Because I want a probability, that's my NCR, PR, Q, N minus R. And of course, I have a song for this formula. I'm going to write down my N, my R, my P, my Q. The N, how many days are there? 5. Out of those 5, I want at least 3. At least 3 means 3 is the least it can be, and I count up until I get to N. The opposite of at least is at most. If it was at most, it would be 3, 2, 1, 0. P is the probability the bus will be late. That's 1/3. It gave it to me in the problem. Q is the probability it won't be late. If the probability it will be late is 1/3, then Q is 2/3. They have to together add to 1. So I have 1, 2, 3 separate problems here. So because there's 3 separate problems, I know that this is going to be a 4-point question. If it said exactly, then it would be a 2-point question. P is 1/3 to the R, which is 3. Q to the N minus R, which is 2. That's my first expression. Next one, 5C4. 1/3 to the 4, 2/3 to the 1, because 5 minus 1 is 4. 5 minus 4 is 1. 5C5. 1/3 to the 5th, 2/3 to the 0. What do do I do with these three expressions? I add them together. So I'm going to go to my calculator. I'm going to type in each one. I have 5 math C3 1/3 to the power of 3 2/3 to the power of 2. I want my answer to be a fraction. It is a fraction. Great. Now, instead of retyping the whole thing, I'm going to just replace the R. Instead of 3, I'm going to put 4. And I'm going to put 4. And I'm going to put 1. And then I'm going to do the same thing here. This is going to be a 0. This is going to be a 5. This is going to be a 5. So I have 1 over 243, 10 over 243. So I got 40 over 243. I've got 10 over 243. I've got 1 over 243. And again, I'm going to want my calculator to do the work for me, so it's less likely to make a mistake. So I'm going to do 40 plus 40 over 243 plus 10 over 243 plus 1 over 243. It reduced it for me. I get 17 over 81. I showed a lot of steps along the way. That way, if I do make a mistake, I can get partial credit. If you try and do the whole thing in the calculator, you mess something up, you're not going to really get any points. Make sure you know your difference between at least and at most. At least is that number and everything above it. At most is that number and everything below it, including 0. So, next type of question. Ooh, binomial expansion. I'm going to pause it for just 1 second because I don't know where my keys are and it's kind of bothering me. Got it. All right. For binomial expansion, whenever you have a binomial to a power that's not 2, if I have a binomial squared, I FOIL. If I have a binomial to a power other than 2, I use my binomial theorem. It's on the reference sheet. It's given to you a couple different ways. The key is taking this NC0, A to the N, B to the 0. All right? It's the top one, the first expression, the top one on the reference sheet where it's given. So I know that the formula is A plus B to the power of N equals that. So my A, B, N. A is 3x, not just 3, it's 3x. It's not the coefficient, the whole term. N is 5. So I'm going to start by subbing in. N we said is 5, B 0, 3x to the N, which is 5, negative 2 to the 0. Now I count my zeros up and I count my N's down. 5C1, 5C2, 5C3, 5C4, 5C5. 3x, 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 and I'm going to count 5, 4, 3, 2, 1, 0, negative 2, negative 2, negative 2, negative 2, negative 2, and I'm going to count up 0, 1, 2, 3, 4, 5. Now, technically, what's between all these? Pluses. It's not asking me for the whole expansion. It usually doesn't. It hasn't in a few years. It could, but it's only asking for the third term. The third term, this is my first term. This is my second term, third term, fourth term, not the one with 5C3, which is why I want you to write the whole thing out. Now that I get to this point, all I have to evaluate is that. So 5C2, I can do that in the calculator. 5C2, 5 math PRB C2 is 10. So I've got 10, 3x to the power of 3. Make sure you give that 3 to everything inside the parentheses. 3 to the third is 27. X to the third is x to the third. Negative 2 squared is 4. A negative power, a negative number to an even power is always positive. A negative number to an odd power is always negative. From here, I can just put the coefficients into the calculator. 1080 x to the power of 3. These problems are long, they're annoying, but they're easy. So make sure you get them right. I'd rather do more work and make sure I get it right than do something that requires less work that's more difficult. So I'm happy when I see a question like this. Word permutations. We are arranging the number of letters in a word. Very simple formula. Number of letters factorial over repetition of each factorial. So let's write it nice and big. Arrangement. And let's take a look at the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The top is 11 factorial. Now, repetition of each, be very careful, because if you miscount, you're getting the question wrong. Let's start with A. There is 1, 2 A's. So I'm going to write 2 factorial. I'm also going to cross them out. That way I don't miss something. R's next. I have 1, 2 R's. 2 factorial. N. 2 N's. G. Only 1 G, so that one's fine. E. 2 E's. So I write 2 factorial. M, there's only 1 M, so I can just cross it out. T, there's only 1 T, so I can just cross it out. I have my expression, 11 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial. Alpha y equals enter this thing. Before alpha y equals enter existed, this thing was a lot of mistakes were made on this. Now, shouldn't be an issue. 11, math PRB factorial over 2 math PRB factorial, 2 math PRB factorial, 2 math PRB factorial, and finally 2 math PRB factorial. 2, 4, 9, 4, 800. That is choice 1. 2,404,800. Make sure you know how to do that. Very common. Make sure you get it right. Statistics. Sweet. Bias is bad for a survey. Random is good. It says which survey could create bias, so it's asking for a bad answer. The size of the sample, 2,000 students were asked in a university. That's fine. The size of the population, you can't control the size of the population, that's fine. The method of analyzing data, I'm sure they did a good job putting the pieces together to come up with that 515.7. The method of choosing the students who were surveyed, well, who did they choose? Every 10th student entering the library was surveyed. Is asking every 10th student entering the library going to give you a good idea of how the whole school studies? No. People that are going to the library are going to the library to study. They, in general, will be studying more than the average person at university. So that will create bias. Their results will probably show you that students study more than they actually do. A better way to do this was to ask every 10th person getting lunch in the student union. That would be random. So, controlled experiment as opposed to observational study. Controlled experiment. Researcher randomly divides whatever people study into two groups and administers the experiment. In a controlled experiment, the person doing the experiment actually does something with the group. He gives them a drug. He separates them. He puts things in sunlight. That's what a controlled experiment is. An observation, or an observational study, is where the researcher observes but does not influence or intervene in the experiment. So, because he collected the eggs, he divided them into two tanks, he put both tanks outside, and he covered one of them to block out all the sunlight. Howard's was a controlled experiment, because he did all of that. Now, in number 89, Darryl is looking at the statistics of baseball players during the steroid era as compared to the non-steroid era. He's not giving people the drugs. He's just looking at the statistics based on what happened. This is an observational study. Because he didn't separate, he didn't go into the locker room and go to the Cleveland Indians and say, okay, you're all taking steroids. Go to the Red Sox, say you're not, and then show what happened. He didn't do that. He just looked at the data and made his conclusions from there. That's the difference between observational study and a controlled experiment. Again, I think this question's a lot nicer than some other questions as far as the difficulty level, so make sure you get it right. Let's just quickly talk about what a census is. A census is also called a population survey. And a population survey is where all members of the population are surveyed. So if I want to find out how the whole school feels about a soccer program, if it's a census or a population survey, I have to talk to everybody in the entire school. If I'm doing a sample survey, which is generally what you do, I would randomly ask every 10 student coming to school in the morning. Which brings us to R. R is your correlation coefficient. The best correlation coefficient is -1 or 1. The worst is 0. It has to be between -1 and 0. So it can't be 1.2. It's not possible. It has to be between -1 and 1. So it wants to know which value of R represents data with a strong positive linear correlation. If it's positive, it's got to be positive. There's no negative answers here, so that's not an issue. It can't be more than 1, so that's out. Which one's closest to 1 without going over? Choice 1. The weakest would be choice 4. Again, if you're looking at something like 98, what determines how strong the correlation is R. The rest of this does not matter. So the answer in this case would be choice 4, because negative 0.8924 is closer to negative 1 than anything else is closer to 1. Basically, the absolute value of R has to be close to 1. All right, linear regression equation. Simple, but be cautious. A lot of areas to lose points on these questions, even though they're pretty straightforward and simple. Make sure you round correctly, and make sure you read very carefully. First of all, it says let x equals 0 represent 1980. So I'm not going to type 1980 into the calculator, I'm going to type 0. How many years after 1980 is 1985? 5 years. 1990 is 10 years. 15, 20. So I'm going to go to my calculator, I'm going to type in this data. Okay. So I hit stat, that's not stat, stat, edit. And I got 0, 5, 10, 15, 20. I've got 14, I've got 20, I've got 22, I've got 28, I've got 37. Stat, count, pick the appropriate regression. This is a linear regression, so I go to choice 4, which is linear regression. Choice 8 is also linear regression, but we're used to ax plus b, not a plus bx, so I'm going to stick with that. X list should be L1, Y list should be L2. You should never have a frequency list for regressions. You can have it for measures of central tendency, but that's it. Now, I'm not seeing my R values here. So to get my R values, I have to go to mode. I have to turn my stat diagnostics on. So now when I repeat the process and go stat cal 4, I'm going to see everything I want. So what does it want me to round to? It says write a linear regression equation to model the data in the table. Let x equals 0 represent 1980. Does it tell me to round to anything? No. Don't look to the next part of the question. This is a separate question. Because it does not tell me to round to anything, I'm not going to round to anything. I'm going to start by writing y equals ax plus b. I'm going to write a equals. I'm going to write b equals. I'm going to not do that. I'm going to get my calculator back. A is 1.08, B is 13.4. And another common mistake, students don't actually write the equation. The equation is y equals 1.08x plus 13.4. Make sure you write the equation with a y and an x. Next question, state the linear correlation coefficient rounded to the nearest hundredth. Well, the linear correlation coefficient is R. To the nearest hundredth, well, let's go to my calculator. It's 0.9781. Because it wants me to round to the nearest hundredth, I draw a line after my second decimal place. The next digit is 5 or higher, it's 8, so it becomes 0.98. There's another question. Using this equation, find the projected enrollment in 2016. Well, 2016 is X because that's the year, but I'm not going to type in 2016 because, again, X is years since 1980. So what I'm going to do is 2016 minus 1980, which is 36, and that's what I'm going to sub in for X. So it's going to be y equals 1.08 times 36 plus 13.4. I'm going to go to my calculator. I'm going to type that in. 1.08 parentheses 36 plus 13.4. It wants me to round to the nearest 10, which is 52.3. Notice, there's 3 questions here. Each question asks me to round to something different. Be very, very, very careful rounding the appropriate values. This is a 4-point question. If you did everything right, but rounded everything to the nearest 10th, let's say, you would have gotten a 2 out of 4. We don't want to throw away points on something like this. Be very careful. I do want to do an exponential, just so you see it. So let's quickly do the exponential here. I don't know why I maximize that. I need my calculator. Again, it's asking for the exponential regression equation. So I just go to my calculator and let my calculator do the work for me. Stat, edit, clear this out, and 0, 2, 4, 6, 8, 10, 12, 16, 25, 36, 52, 68, 85, 104, 142, 260. That count, because it wants exponential regression, I scroll down to 0, which is exponential regression. Let's just talk about everything is here. 4, we know 4 we said was linear regression, which is common. 5, quadratic regression, don't expect to see that. 6, cubic regression, don't expect to see that. 7, I don't know, quartile regression, don't expect to see that. 8, again, is linear regression, but we don't need to use that one. 9 is very important. 9 is logarithmic regression. They only asked it once, but you could see it. That's logarithmic regression, choice 9. Option 0 is exponential regression. A is power regression. Haven't seen that in years, but they used to ask that a lot. And that's it. Logistic is not logarithmic regression. Choice 9 is logarithmic regression. Anyway, choice 0, exponential regression. X is less than L1, Y less than L2, frequency list is empty. Calculate. Now, they give us this star and this parrot. We don't write things like that in high school. They updated all their software, yet they still make that weird. I don't know what to tell you. I write it y equals a parentheses b to the power of x. It asks me to round to the nearest 10,000. That's 4 decimal places. So I have 27.2025. And I have 1.1509. So to write the equation now, it's y equals 27.2025, 1.1509 to the power of x. Make sure you write the actual equation. Now it says, using this equation, predict the number of single-celled organisms, nearest whole number at the end of the 18th hour. 18, is that x or is that y? Hours is x. Be careful if the units match up. Hours, and if not, you might have to do a little conversion. So, y equals 27.2025, 1.1509 to the power of 18. If it gives me x, it's easier because I can just sub in. If it gives me y, I'm going to have to solve the equation. Just be aware of that. You might have to solve the equation. If it gives you y, hopefully you know how to solve your equations. For an exponential equation, you'd have to isolate and then do log on both sides. Again, I don't have to do that here. It's a little bit easier, but you are responsible for solving all types of equations. It wants me to round to the nearest whole number, which is 341. I think I'm going to have to pause this for now because I have students coming in to take a practice exam. All right, we're back. We may or may not have some company now. The live show is rare, but some people get lucky sometimes. What can I say? We are up to 106. When it's asking about the range, the mean, the standard deviation, we need to go again to our calculator, type the data in. So I'm going to go to Stat, Edit. I'm going to clear this out of here. Because there is a frequency list, I am going to type the frequency in to L2. 1, 3, 2. Stat, calc, one variable statistics. Because I have a frequency list, under freq list, I'm going to hit second 2 to get my L2 and tab down to calculate. Now let's talk about what everything represents here so we don't have to do it again later. The first thing, the x with the bar over it, that's your mean. Sigma x, this is your population. That's not going to work. Standard deviation. Again, that's sigma x, not fx, sigma x. I can scroll down. I have some more information there. I have my mins, pretty self-explanatory, my lower quartile, my median, my upper quartile, my max. So, for this particular question, I need my range. I need my interquartile range, and no, I don't need my interquartile range. I need my range, I need my mean, and I need my standard deviation. Range you need to know is max minus the min. So let's go and get my data. Max minus min is 14 minus 8. Is 6. My mean is 11. And my standard deviation is 2.2. So now I'm looking at each choice. Does my range equal my mean? Does my 6 equal my 11? Nope. Is my range greater than my mean? Is 6 greater than 11? Nope. Is my range less than my mean? Yep. Is my range less than my standard deviation? No. As a little bonus, let's find our interquartile range. So let's do another problem later. This is probably what they ask the most. Mean, standard deviation, interquartile range. If I'm an interquartile range, I'm doing Q3 minus Q1. So for this particular problem, my Q3 is 14. My Q1 is 10. So 14 minus 10 is 4. My interquartile range would be 4. So the calculator does all the work for you. Just be careful with the frequency list. If there's a frequency list, put L2 into the frequency list. If there's not a frequency list, clear it out. I think we are going to, what else do we got here? I think we're up to normal distribution stuff, so we will do that at another point, potentially. And that's it. See ya.